More geometry review for your ACT, MCA prep. Scale factors, ratios, and how to use them. First, when we have shapes, we have areas, we have surface areas, we have volume, we have perimeters. You have to know what dimension you're talking about. Now, if I'm talking about a perimeter, that's a one dimension. So when I'm talking about ratios, a scale factor is the same thing as like comparing two perimeters. So I'm going to do scale factor because you're going to see me making this chart. So my scale factor also is talking about perimeters. My scale factor here comparing my two shapes would be 3 to 4. Now if I want to find my area ratio, or else you might see me do it like this, scale factor squared. When I'm talking about area of any shape, we always say units squared. Well, that's the same thing as a surface area, or just area of any shape. You want to take your scale factor and square it. So you're going to square the top and the bottom. So my ratio for area for this shape would be 9 over 16. Because 3 squared is 9, and 4 squared is 16. Now when you're talking about volume, volume is always going to be like your scale factor, but volume units are always cubed because it's a 3-dimension. So in this case, we take our scale factor 3/4, again that's like a perimeter, and cube it. So 3 cubed would be 27, 4 and 4 cubed is 64. So I'd like you to pause the video and try to set up these three ratios, the scale factor ratio, the area ratio, and the volume ratio for this other set. Remember, when you're writing ratios, you always want to do it in simplest form. So pause the video and see if it's the same as mine. So pretty much the same thing. 12 divided by 9, both of those are divisible by 3. So we have 4/3 for my actual scale factor ratio. And then we square it for my area ratio, which is 16 over 9. And volume ratio is 64 over 27. Once you reduce, you should not be able to reduce your area or volume ratio. So here's a word problem. It's not uncommon to see a lot of word problems with ratios. You have to be able to know what you're talking about and how to set the problem. There are 12 pencils in a regular sized box. If a jumbo box is made by tripling, so it's always good to draw a picture. So this is a regular sized box and there's 12 pencils inside. And then the larger box is tripling each side. So you have to think about this, and they're asking how many can fit inside this box. So when I'm looking at my side lengths, my scale factor ratio, my ratio between the two shapes would be 1 to 3. Now, when you're thinking about 12 pencils, that's a volume question. Asking, there's normally 12 pencils in this problem. So first thing you have to do is figure out what is your volume ratio. Remember, volume ratio is taking your scale factor, your perimeter, so this would be 1/3, and cubing it. So my volume ratio is 1 over 27. The reason why we need that is we have to take your volume ratio and set that equal to what you're looking for. There are 12 pencils in my original box, and then I want to figure out how many are going to fit in my new jumbo box when I tripled each side. Each side is the 3-dimensional shape. And so then here I have a fraction equal fraction. When you have a fraction equal fraction, you cross multiply. So I get x is equal to 324 pencils. So it's knowing what equation or what ratio to set equal to your desired information. Seriously, pause it. So here, your answer should be 53.78 meters squared. Now when I'm looking at this, my scale factor right here was 12 over 18. My smaller was 12 over 18. I reduced that to 2/3 because I just think it makes math easier when you reduce. So I'm looking for my area ratio. Area ratio is going to be my scale factor squared. 2 squared is 4, 3 squared is 9. So it's having my area ratio equal to the area that I'm looking for. So if I cross multiply, these two cross multiply, and then divided by this, I would get 53.78 meters squared. So this problem, another word problem, you have to try to know what am I looking for, what am I trying to get at. It already gives us the scale factor is 4 to 3. Okay, but now I have to figure out what am I looking at. It costs $216 to refinish the smaller piece of wood. At that rate, how much would it cost to refinish a larger wood? Well, you have to think about wood floor, and what refinishing mean is basically kind of like painting the floor. So when you're painting, you're talking about the area. So if this is my scale factor, my area ratio is what we're going to have to use. So I have 4/3, and my area ratio would be squared. So my area ratio is 16 over 9. Now, be careful when you're setting this up. It says it costs $216 for the smaller wood floor. So when I'm looking at this, the 216 has to be across from my smaller ratio. Those match up. They have to be across from each other. Again, when I'm talking about refinishing a wood floor, that would be the area of something. So now I have equal to X. I want to figure out how much would it cost for the larger wood. And I would cross multiply. And I would get that would cost $384. And that's it. That's my 8. Well, now I'm making it worse. Whatevs. An embroidered placement costs $3.95. Now, just reading this, an embroidered placement, so that's talking about something that's two-dimensional. Okay, so two-dimensional is going to be area. I'm talking about the area of something. So I'm going to keep reading. Tablecloth is similar, but is 4 times larger. So it's already telling us what the scale factor is. My original placement is 1, and it's 4 times larger. So my scale factor is 1 to 4. Now that's the scale factor. It says, how much would you expect to pay for the tablecloth? Well, I'm talking about my area because it's two-dimensional, so you need to do 1/4, and you need to square that. So my area ratio is 1 over 16. So I set up my equation, 1 over 16, because I need my area ratio when I'm finding the area. So it costs $3.95. So I have to cross multiply. And I get that it would cost me $63.20. So these problems, I'm giving the area, and I want you to tell me what the scale factor is, and I also want you to tell me the volume ratio. So first, when I'm doing these first two, these are actually 4 different problems. So this first one right here, number 1. I have 4 over 16, and that's my area ratio. Now, if I want to go backwards to my scale factor, I have to take the square root of that. So the square root of 4 would be 2, and the square root of 16 is 4. So I can actually reduce that, so my scale factor would be 1/2. That's my scale factor. The area ratio was 4 over 16, or again, that could be reduced to 1/4. So now when I'm looking for my volume ratio is my scale factor, but cubed. So it would be 1 over 8. So these would be my 2 answers. So now I'm looking at my 2 triangles. And a lot of times this is the chart that I set up. Scale factor, area ratio, and volume ratio. That's what I'm going to look at. So my 2 triangles have the area of 75 and 12. I always like to first reduce that fraction. So 75 and 12 are both divisible by 3. 75 divided by 3 is 25, and 12 divided by 3 is 4. That way when I work backwards, so working backwards over here, I have to take the square root of 25 over 4. So my scale factor, square root of 25 is 5, square root of 4 is 2. So that's my scale factor. Now if I want to move forward to my volume ratio, it's going to be my scale factor ratio, but cubed. So 5 cubed is 125, and 2 cubed would be 8. So these would be my two answers. I'd like you to try to pause the video and try to do these two by yourself, doing your whole chart. So here, this first one is purple. So I wrote down 18 over 32 first, and then I simplified that fraction. Both of these are divisible by 2. That's how I get 9 over 16. I took that and I took the square root of that, because working backwards from something squared is the square root. So the square root of 9 is 3, square root of 16 is 4. And then I took my scale factor and cubed it, because volume is cubed. So I cubed that and got 27 over 64. Same thing here. These square root 3's cancel each other out. So when I wrote those over top of each other, I got 16 over 1. Square root of that would be 4 over 1, and cubing that would be 64 over 1. It's the same type of thing I want to do here. I want to figure out what my scale factor is. I want to figure out what my area ratio is. And I'm given my volume ratio. So my volume ratio here is 250 pi over 432 pi, because I'm comparing my two volumes. Now if I simplify that, both of the pi's can cancel out, plus both of those are divisible by 2. So 250 divided by 2 is 125, and 432 divided by 2 is 216. Now when you're doing this, you always want to get back to the original first. So in order to figure out my scale factor here, I have to take the cubic root of 125 over 216. So the cubic root of 125 is 5, and the cubic root of 216 is 6. Now, there is a cubic root button when you push math on your calculator, or cubic root is the same thing as 1/3 power, so you can raise it to the 1/3 power. Do 125 to the 1/3 power and 216, so it separates them. Now, if I want to get from my scale factor to my area is squared, so if I square that, my area ratio is 25 over 36. So not a word problem, but this could be the given information in a word problem that you have to decipher through. I'm given the two surface areas. A lot of times the reason why I'm practicing these charts is so that you can figure out what I'm working with. And I have my area ratio and I have my volume ratio. So first when I look at what am I given, I'm given surface area. So that's my area ratio. So I'm going to write that in my area ratio column. Now, you should always simplify your fraction if possible. Both of these are actually divisible by 62. I know. Difficult. How will I ever know if it's divisible by 62? Try to just keep on keeping on. So both of those divided by 62 would be 4 over 9. So I first need to look for my scale factor. So I have to take the square root of 4 over 9. So my scale factor here would be 2/3. Why am I doing this? I am looking for my volume. I'm given my two surface areas, and I want to figure out what my volume is. And I'm given the volume of the larger. I didn't actually write that in. So if I'm looking for volume, I need my volume ratio. So now I have my scale factor, and I take my scale factor, and I need to cube that, because I'm talking about volume. So scale factor 2/3 cubed would be 2 cubed is 8, 3 cubed is 27. So now I have my volume ratio. So my volume ratio can help me find the volume of anything that I need to know here. The volume, my larger one is 810, so that has to be across from my larger ratio. So the 810 has to go here, and the x above. So again, here I have to cross multiply and divide, and I would get 240. And I have inches cubed here, because volume is cubed. And that's all I have for you for talking about ratios. A lot of times, though, the ratios will be set up as a word problem that we have been dealing with. So you have a wonderful evening.